key. Look at the rooftops. Look at the balconies. Heck, look at the fields. Those black-blue plates are everywhere. But have you ever wondered, what exactly do they do? You say, they generate solar energy. Okay, but how? Does sunlight hit a plate and electricity just comes out? Or is there a tiny wizard inside? Today I'm going to tell you the story of solar panels, how they're made, and how they work, without being boring about it. Promise. The year is 1839. A 19-year-old French physicist named Edmond Becquerel is in his lab, dipping two metal plates into a container filled with acid. And the moment sunlight hits them, electricity flows. Wait, what? Says Becquerel. And people spend the next 100 years trying to answer that question. Then, in 1954, scientists at Bell Laboratories build the first practical silicon solar cell. Efficiency? 6%, meaning they could convert just 6% of incoming sunlight into electricity. Today, that number has climbed to 20% to 25%. And it's still improving. The first solar panels were so expensive they were only used for space satellites. Think about it, not for your rooftop, but for strapping onto a rocket. But over time, prices dropped, technology improved, and today, they fit on every home, every balcony, even every backpack. So how are these plates actually produced? Let's dive into the factory. Step 1. Silicon. It all starts with sand. Yes, beach sand. The silicon inside the sand is refined at extremely high temperatures until it's pure. So pure, in fact, that almost no foreign atoms are left inside. At this point, it's one of the cleanest substances on Earth. Step 2. Growing the crystal. The pure silicon is melted down and a seed crystal is dipped into it. It's slowly rotated and pulled upward, forming a large silicon cylinder, an ingot. This process can take 3 to 4 days. No rushing here. Step 3. Thin slices. The ingot is cut into very thin slices using a wire saw. Each slice is a wafer, the core material of a solar cell. How thick? About 0.2 millimeters. Thin as paper. Step 4. Chemical magic. The wafers go through a chemical treatment process. Phosphorus is added to one side, boron to the other. These two different materials create an electric tension inside the cell. I'll explain this in just a moment. Don't worry. Step 5. Metal grid and coating thin silver lines are printed onto the cell. These will collect the electricity. Then, an anti-reflection coating is applied, giving it that blue-purple color. Thanks to this coating, more light enters the cell instead of bouncing off. Step 6. Assembling the panel, dozens of cells are brought together, placed under a sheet of transparent glass, framed up, and you've got yourself a solar panel. Now the real question, what happens when sunlight hits the panel? This is where physics steps in. But don't worry, it's not scary. Just picture it like this. It's called the photoelectric effect. Sunlight is actually made up of tiny packets of energy, called photons. When these photons strike the panel, they knock electrons loose inside the silicon. Think of it like throwing a ball. The photon comes flying in, goes, hey, and smacks an electron. And the electron goes, ow, what was that for? And shoots off. These freed electrons are then forced to flow in one direction by the structure inside the panel. And electrons flowing in one direction equals electric current. But wait, this current is direct current, DC, not the alternating current, AC, we use at home. So an inverter steps in and makes the conversion. After that, it flows to your outlets, your fridge, your phone charger. In short, sunlight to photon to electron movement, to direct current to inverter, to alternating current to your home's electricity. That simple. No moving parts, no engine, no flammable materials, just light, material, and physics. Solar panels are currently the fastest growing energy source in the world. Why? The sun sends free light. It doesn't send you a bill. Panels last 25 to 30 years. They genuinely pay off in the long run. No carbon emissions, no smoke, no noise. And prices keep falling. They've dropped more than 90% in the last 10 years. Think about it. Putting solar panels on your roof was considered a luxury just 10 years ago, something only the wealthy could do. Today, in some countries, it's the cheapest way to generate electricity. And 10 years from now? Who knows? So there you have it. A discovery made by a young French guy back in 1839 is now alive on millions of rooftops, fields, and even space stations. A grain of sand after a long journey gives you clean electricity. Not bad, right? If you enjoyed this video, hit follow. Next time I'm talking about batteries and energy storage systems. Because we want the sun to work at night too, don't we? See you next time. If you liked the video and want to watch more like it, please hit follow.